Okay, we are recording. Welcome to this month's webinar from the Immersive Learning Bootcamp on AI and education. Today we're going to focus on natural sciences and healthcare, and I'll be leading off, and then we'll have Rob Jung step in a little bit on down the road as we move further into it. So we're just going to get right into it. I'm David Anderson. I'm from St. Cloud Technical and Community College. We are an NSF-funded project that is focused on XR technologies, but we're also getting into AI. And today we're going to talk about uh, kind of two different perspectives, starting out with some benefits of basic usage, and then I'm going to get a little deeper into more advanced usage, but basic, starting out with some ideation, some content creation, and then personalization of how we can make it useful for students. I do apologize for the small text on this. You can download this presentation from our website. If one of you want to pull our website and put it into well, I guess they can find it. We'll have it on it won't show up in the chat on the recording anyway. But this is a long prompt that would be useful for an online laboratory for a chemistry class. Tried to, as I put this together, look at different healthcare and natural science perspectives. But one of the things that we generally find is with online classes, how do we help students explore laboratory concepts in their own home, and especially if maybe we don't have lab kits or we don't have access to those facilities. So I tried to make it something that they could do with things that are around the house. So this is looking at pH and things that they could do. We can use red cabbage to make pH paper, and we can test acidity and basicity um, with home solutions. So this is the prompt that we would use, and it would create the laboratory based on that. Here's another one. We can use gamification in our face-to-face classroom. Here is one for dental hygiene, looking at a way to gamify the student experience when they're in class. Um, Interactivity and engagement, specifically looking at here. Again, fairly long, but the one thing I found with AI is the longer that we make the prompt, the more detailed we make the prompt, the better result we get out of it. And this is one looking at biology, looking at content. We can create quizzes. This is just a 10-question quiz. And I did run this one and actually came up with some pretty good questions and answers. If I take it a little bit more detailed, I wanted to make it so you could actually read it. But you take a little more detail, then it would also create the feedback that we can load into either our learning management systems, or that we could have for students to say, this is wrong because, or this is correct because. It's pretty good at doing that as well. Here's an online discussion board prompt looking at physics. One of the things that I have found is my discussions sometimes get a little stale. I'm not always the best with being creative and what I want to the questions that I want to ask. And AI has a really good, actually, there's some good research out there showing that ideation with AI, with one person doing it, is actually better than getting a circle of PhD faculty together. You get better ideas with one person using AI than you do out of um, a group of faculty. So it's really good at these ideas of trying to be creative and looking at different ways to do things, different questions to ask. Looking at a lesson prompt here, Matt, I took this concept from you from last month, looking at how can we create a full lesson, 45-minute detailed lesson plan, looking at phlebotomy. And when I ran this, can't say that I'm an expert in phlebotomy, but it seemed like it made sense as far as how it would walk students through these concepts. And another one again here on practical nursing, looking at trying to personalize it for how can we incorporate concepts like cultural responsibility or cultural cultural responsiveness. How can we make the classroom more personalized for different groups of people, more individual students? And it's a great way to have students think through as they're getting out into their field, how can they also incorporate that into their work? So those are some basic things that we can do. And then I did a little bit deeper dive into what else can we do? That's all text generation. What can we do beyond that? And I started looking at things like audio and video. And here is it's just a 5-minute lecture creation. I didn't actually run this one, but it was a pretty detailed prompt to look at uh, a podcast concept, but looking at chemistry and the basics of water, bonding. This can be used across multiple disciplines, including chemistry, biology. Um, the ones I did run and actually worked through, I did a translation prompt, and I can't say that I know its accuracy. I really love to run this past faculty that know the different language, but
Bienvenidos a Química
can you hear
Descubierta,
that?
donde exploramos la ciencia detrás de lo que nos hace, bueno, nosotros mismos.
So moved on, but I took a lecture prompt, I translated it into Spanish, took the Spanish, took that to 11 Labs, which is a text to voice generator, and then chose a voice that was a conversational Spanish woman. And like I said, I don't know if it's accurate, but it might help students that aren't native English speakers be able to access the content a little bit better than those than they otherwise would. I took a little bit more time with this one. I created a podcast. Now, if you think about a podcast, you think about, okay, I've got to find the expert, I've got to come up with my questions, I've got to be a good interviewer, we've got to make the recording, and then I've got to go in and do all the editing. And think about how much time that would take. I used this prompt. It took a little time figuring it out, but I was able to have the AI write the losing the word here, had it write the script for both the interviewer and the interviewee. I had it group them so that it was all of the interview questions and all of the interviewees' responses. I took that again, to 11 Labs. I had that run and generate the output. Took that and went to an online audio editor, which was free. Now, with that, I could only do 4 minutes, but if we have access to Adobe Premiere, we can do this as long as we want. And then created a podcast. Again, it goes backwards. Give me a second here. So here is.
Welcome to Nutrition Insights, where we dig into what we eat and how it affects our health. I'm Jennifer, and today we're diving into a hot topic in nutrition: seed oils. These oils are found in so many foods, from salad dressings to snacks, and have sparked a lot of debate recently. Some experts believe certain seed oils may contribute to inflammation and long-term health issues. Here to help us unpack the science behind seed oils is Dr. Frank Martin, a nutrition expert and researcher. Dr. Frank, thanks for joining us.
Thanks, Jennifer. It's great to be here. Seed oils are definitely a popular and sometimes controversial topic in nutrition right now.
They really are. So let's start with the basics. What exactly are seed oils, and why are they so commonly used in our food?
That's a good question. Seed oils come from seeds like soybean, sunflower, corn, and canola. They're popular because they're inexpensive to produce and have a long shelf life, making them ideal for processed foods. You'll find them in many packaged snacks, fried foods, and even some healthy salad dressings.
So I'm not going to run the whole podcast of that. There are a few glitches here and there, but overall, it's a pretty decent podcast. As the expert, I can determine whether or not the expert is giving good and accurate information. And the AI comes up with some pretty good questions and pretty good responses. And I did all of that in a half hour. And that was including trying to figure out how I was going to do the audio editing and where I was going to do the editing. If I just opened up Premiere, it would have taken me a lot less than that. So you think about creating these podcasts, which is a very common way for people to consume information today. We can also create that in our class and allow students who are maybe more, they like auditory things, they can do things while they're listening and still get the information just in a different format. Now here's a really long one because audio takes a lot long, or video takes a lot longer. And again, you go online to our website and you can download this and get the entire prompt rather than trying to read through this. Video's tough. Video is not great yet. This is I'll run it here. It's a scenario.
You step into the bustling emergency room, the air thick with anticipation. A sea of faces, some etched with worry, others stoic, surrounds you. Your gaze falls upon a middle-aged man, visibly struggling to catch his breath. This is Mr. Smith, a 52-year-old male who arrived complaining of shortness of breath and chest discomfort. His face is pale, beads of sweat dotting his forehead. His chest heaves with each strained breath, a testament to his body's death.
You can see it doesn't really match up with what the narrator is saying. It's got some nice stock videos to it. The idea here was to give see if I can go back. Here we go. 5-minute scenario-based video designed for nursing students in a clinical assessment course. Should stimulate a patient intake scenario where students access a patient with symptoms of shortness of breath and chest discomfort. Scenario should allow students to make choices that affect the video's progression and include guided feedback for learning. And then here's all the elements. So the videos, it doesn't do all those things because the video creation isn't there yet. But it's getting there. And if we keep an eye on it, it's going to be there pretty quick. So definitely something to be considering as we move forward. Oh, come on. There we go. So some other things, data security. Within Minnesota State, we all have access to Copilot. We should not be putting any student private data into any AI except Copilot. So this is looking at a 5-step process to anonymize student data so that when I do use AI tools, it's in a FERPA compliant state. So it's a way to ensure that what I'm doing, hopefully, is going to maintain student privacy. And it would give you that step-by-step on what you need to do. Another deeper dive into it is looking at AI customization. I have several GPTs that I use that I've personalized. I also like Perplexity, which has libraries. Gemini has what's called gems, and Claude has projects. Unfortunately, Copilot has nothing. It does not yet have the ability to customize it, which is very frustrating. It might eventually, it used to, then they took it away. Hopefully they'll bring that back at some point. But this ability to customize the GPT or the AI into what it becomes specialized, so it gets really good at certain things, makes it a lot more useful. At least that's what I've seen. And then we finish out here these. Oh, this is looking at students. That's right. So at the end here, finishing up with little student perspectives. There's a couple different ways that you could use it in the classroom with students. So here's a research prompt for students to help them learn something that's a little bit more detailed. So this is looking at something in genetics called CRISPR. So having the AI explain to them this process so it is easy for them to understand. And another way is for them to use it as a practice tool. So generate a question set that they can go through and help them understand specific. This is looking at pulmonary circulation and systemic circulation, so anatomy and physiology. And then these are the AIs that I used to do this. So I use both GPT-4o and Perplexity. With Perplexity, I use Claude Sonnet 3.5. I use text to speech. I used 11 labs for that. For the text to video, I used InVideo. And for the audio editor, I used Capwing. Capwing allowed for 4 minutes of that video creation. And it leaves a watermark and all that stuff, but we'll see on down the line whether or not it's useful. 11 Labs, I do have a subscription, so you can get some things for free. You can get a certain amount of it for free. But if you're going to do very much of it, you're going to need to pay the $11, I think it is, per month to be able to use that. So that's what I have. I'm going to stop sharing and turn it over to Rob. And Rob, you can continue on from here.
Okay. Well, thanks a lot, David. I will get my PowerPoint up here. Let's see. There we go. Okay, so are you guys all able to see that properly?
Yep, we can see it. We see the whole presentation with the slide bar to the side.
Let me do that.
There we go.
How's that working? Okay, so David and I are both teaching anatomy and some of the AI techniques. Well, first of all, I'm Robert Jung. I'm from Northland College in northern Minnesota in East Grand Forks. And as I said, we have a little bit of overlap here because I do use a lot of AI software and technology in my classes for many of the same purposes that David does. But I'm also kind of leaning into XR technology and presentation in my specifically anatomy and physiology laboratories. And so I see that I'm not on the beginning slide here, so I'll jump back to that. So that's the other thing that I'm going to be adding as kind of the tail end of this presentation is some ways in which I've incorporated AI into what I'm doing with XR. So let's go ahead and jump into it here. Classically, some of the real limitations of anatomy classes are that it's expensive to run anatomy classes. Even some of the simple pigs and cats that are part of the dissections are expensive, but especially if you're looking at something like running a human cadaver lab, that can run into the hundreds of thousands of dollars for equipment and maintenance and safety and all of those things. So it typically is not a financially viable option for a lot of especially small schools, especially things like community colleges. And then the other option are these 2D images that you get from textbooks, which don't afford a lot of realism and kind of feeling like you're there. Thirdly, many of the these static images or static models that we have, it's difficult to kind of describe physiological processes that are happening in real time to students. So and then on top of that, you've got fast learners and slow learners, and sort of trying to balance that out usually is a challenge. And the same is true with large classrooms. You're trying to understand the needs of 30 students at a time, and it kind of stretches the resource, especially the human resources there. So we've been using Quest 2 headsets along with some Quest 3 headsets in some of our laboratories. And so I wanted to just talk a little bit about some of our advantages that we're finding using these equipment. First of all, as I said, we have headsets equipment that is enough to utilize an entire laboratory. But we also recently got access to a software suite that's known as Medical Holodeck. And it is typically being used in some of the higher end hospitals in order for doctors to do things like plan surgeries and do training and that sort of thing. And we were very, I think, in the right place at the right time, that we were able to get free access to this very, very powerful program. So thrilled about that. And I'm thrilled to kind of show you guys what we've been doing with it so far. But what that allows you to do is to take full body anatomical models and look at that organ or that tissue or that section of the body layer by layer. It also allows you to manipulate it in 3D space. And some of these models are many, many gigabytes of data. So, we've also invested in some high-end computers to allow us to kind of smoothly surf through these models. Okay, so interaction is where it's at if you're trying to get students to get the most and learn the fastest out of these lessons. So there are virtual dissection tools. You're able to kind of whittle away at these different body systems and tissue and that sort of thing and get to what your topic is. You can zero in on specific organ systems or particular tissues that you're working on for a particular lesson. And as I said, you can manipulate those images really easily with some of the tools that are available on this medical holodeck. And then also there is kind of a layering that is available, which allows you to do things like present organ systems, but also then animate within those organ systems to kind of show a physiological process or animate the image itself. So those are some of the things that we've been working on. Some of the practical applications that we've found using this software is that you can allow a student to observe some of these procedures before a laboratory. So maybe we're doing a heart dissection and it's possible, in face-to-face, and it's possible to allow those students to do a heart dissection in virtual reality or watch heart dissection in like a presentation of one in virtual reality and get kind of a real grasp of it before they go in and do the actual dissection. They can also use this as sort of a post-lab review. So once they've gone through and done the hands-on, they can go back and take their own time to really understand what they just saw, at their own pace instead of, kind of the rushed 2 hours that we usually spend in lab. And these can also be packaged as 2D videos and then sent out to students if they are unable to attend one of these labs. So the other thing, as I mentioned, that we're trying to implement along with this software is the ability to have AI integrated into what we're doing. So part of that plan is to include kind of an AI tracking as to how much time students are spending in a particular lesson, or how many clicks they're doing on the model to kind of see where they're at, kind of measuring what it is that they're getting out of this program. And one of the things that we're hoping to do is to figure out what students are missing, or maybe, teaching students what they know, they think they know, but they maybe don't know. So, kind of working that angle of it. And then just the ability of this software to present material in multiple ways, because there are, you'll see several different ways to kind of approach, in some cases, the same topic or slightly different topics. So as I said, this is where we also are working at trying to combine AI and XR. And so, just as David showed, there's multiple ways of including language. Like he used the example of translating into Spanish. There are ways to set up AI so that students can, within that program, ask verbal questions and then get answers back about particular systems that they're observing. And then, of course, a big part of medical terminology is being able to pronounce these words. So being able to ask, how is this pronounced, and get that immediate feedback is useful. And right now we have Wikipedia directly linked into this medical holodeck. So all students need to do is turn around and click on the pronunciation of any of these terms. It'll automatically bring Wikipedia up to that topic. And then if they click pronunciation, they can get an immediate pronunciation of those terms. Something that is more future oriented than we're able to produce right now is step-by-step guidance through dissection. So, when students have these medical holodeck loaded into their headsets, there will be the future potential of including kind of essentially a lab at home, where they're prompted to and then asked to dissect tissues and that sort of thing. Okay, and then lastly is the one that we've just kind of recently included in these lesson plans, and that is using AI to identify structures in imported medical imagery. So we've now been able to import CT scans and MRI and X-rays right directly into this program. And not only have we gotten files that have been de-identified from the hospitals, but we've also had archives that we've been working with that contain up to 35,000 of these files free for the using in an educational environment. So we'll get a chance to look at those here in a little bit. So some other practical kinds of integration that we've been working on is, having students work on basic tissue type identification and exploration. And this actually is one of the topics that triggered my interest in trying to involve XR into teaching an anatomy and physiology class, because the difficulty of getting students to see the differences between, some of these different tissues and the complexity of it was kind of overwhelming for both me and the students. So, it kind of all grew from there. Things like muscle action visualization, there's a lot of complex moving parts in that process, and to be able to try to have students work through it in this kind of VR environment is useful. And then also things like nerve impulse conduction and synaptic transmission, also several things all kind of moving at once, and it's good to be able to present that in a 3D environment for students. Okay, so this is where I'm gonna maybe switch the source here. So I'm gonna jump to another screen here to share. And so what this is now, can you see that? Are you able to see the image of the virtual holodeck software?
Yep, we can see it, Rob.
Okay, good. So what this is showing is kind of the environment that you're working in this holodeck, and I'm just going to voice over, since we weren't able to get the sound to work for this presentation. I'm just going to voice over what I'm doing. And what you can see, there are three different main parts. There are the imported medical images. You've got what's called an anatomy master. And then just above that is like the cadaver images that you can work with. And what I'm doing now is I'm just scrolling through, and this anatomy master is sort of a simplified version of these anatomical structures. So you can see like chests and cranium and arms and legs and so forth. And it's kind of in a almost a cartoonized version of these structures, but in 3D. And so I'm going to be pulling that up here in just a second. And then you can kind of see what that looks like. So I'm pulling up a model of the thorax right here. And so it's on the outset there, it's a real simple kind of set of muscles around the outer part of the body. And just muscles and lymphatics are visible there, with maybe the sternum bone and so forth. But even here, what you're able to do, and I'll pull this up here in just a second, is to use that dissecting tool that I was just talking about a minute ago. And so this is running a little bit slower than it did in real life, but we should be able to. Okay, so there's the list of all of the structures that are represented in 3D, and I can either have those present, or I can click on the little checks and make them disappear one by one. But what I'll be doing here is using that planar dissection tool here in just a second. I'm gonna maybe just jump ahead a little bit. Okay, so now I've taken that tool, and I've now using it to go through layer by layer through this tissue. And this is not anything that other anatomy programs can't do as well, but it is one of the three sets of software suites here. So you can see all the different vessels and organs in the thoracic cavity, and it's kind of classic type of 3D visualization here. So I'm going to jump ahead here a little bit, and I'm going to show you the next level of complexity that you can use with this program. And that's going to be the dissection master. So this will show a little bit more of the cadaver style dissections that you're able to look at. And so this is a human lower trunk and pelvis anatomy. And again, this is multiple sections. You're able to kind of pan your way through the different organ systems and so on, and give a student a real feel for what it might be like to do a cadaver dissection. So again, I'm going to jump ahead here a little bit. And I'm just kind of showing some of the various features here. And so what this next one is showing is a dissected heart. And the difference here that you'll see is that now there's a combination of the cadaver heart along with animation. And so this is something that you can add to any one of these lessons that you're interested in. But this is showing an amazing amount of detail. Down at the bottom is the heart itself with the various chambers, red representing oxygenated blood, blue representing deoxygenated blood. There also are some of the vessels up at the top of the heart. And what you're seeing right there in light blue is the air entering into the lungs of this individual. So that's actually a partial view of the lungs as well. Okay, so I think I turn this model here in just a second. Yep, and so this is kind of the other part of the model showing the right atrium there where the deoxygenated blood is flowing into the system. You're also seeing the trachea where air is rushing into the lungs, and then some of the other minor vessels there. So this is a tremendously useful tool for teaching students, you know, the complete cycle of blood running through the cardiovascular system. And as I said, this is taking that dissection tool and allowing you to, you know, remove parts that you've already maybe described and have students take a look at the inner structures of that heart, including valves, including other kind of minor structures like nerves and internal blood vessels and that sort of thing. And then what you're seeing here are all of those different dots representing individual structures that, again, students can use this on their own time and work through all of those different anatomical structures. So I'm going to move ahead here a little bit more. And so this is the final part here. And this is where I'm going to show a import of a medical scanned image. And this is a CT scan. And specifically, I had this CT scan done of myself about 3 years ago. And it wasn't voluntary. I was in the hospital for a respiratory problem. But you can see here that there is a scan of a chest cavity. And so we'll pull that up and enlarge it a little bit. But what is different about this scan is that this is what we've already used AI on. And so you can see kind of a hint of different colors there. What AI has done is it's gone into the CT scan, which is generally just one color. It's basically, you know, generated images of all the different organs, but that AI has gone in now and colored every one of those different organs with its own code. And so you can see the couple lobes of the lung there in different colors, and on the right hand, the left hand side of the patient, it's showing that lung as a third different color, but you can see the you know, the different organs, the liver and all the major vessels, all color coded for you. So you know, at this point you could go in then and then add those little identification dots that you saw on the last screen, and it would allow students to kind of see these images, see the different organs, identify them as their type. And I'm just showing there the backbone that this AI went through and decided to, you know, color each one of those backbone vertebra a different color. They're tremendously useful. It makes these images amazingly easy to teach with after this process has been carried out. Okay, so that kind of wraps up the video, and I'll just go back to sharing the last little bit of my talk. And yeah, so here we are, and then you know, what I do here is just hype things up a little bit and mention that, you know, use together some of this AI technology along with, you know, it being able to work right inside this virtual dissection laboratory is tremendously powerful. And because students can, you know, go through the lesson in person and then maybe get this version of it to work on their own time, it can kind of enhance these two forms of presentation, can kind of enhance each other quite a bit. And you know, there's a lot of research out there that's showing that these multiple ways of presenting this information can provide deeper learning and then also an accelerated learning curve for students. And then you know, I'm happy at this point to open it up to any questions that people might have.
Rob, I'm gonna switch out your slide. Just so we have the surveys uh,
Oh yeah, right.
on there. So we added that at the last minutes and didn't give you back the presentation. Yeah, so anybody with questions on either of the presentations today, we are definitely open to those. Otherwise, we're also going to be posting these. You'll be watching them online, and you're welcome to reach out to us with questions there as well.
For sure.
That was,
yep.
as someone who teaches anatomy and physiology as well, Rob, that's pretty awesome. The ability to get students into that and the customization that you can do now compared to what it was even just a few years ago is pretty awesome with the AI integration.
Yeah, and I've seen, you know, I've gone to a couple of the kind of webinars that this company, this medical holodeck has put together, and got to listen to some descriptions of doctors who use this AI and use this visualization on surgical planning. And it is astounding how some of these surgeons are sort of pioneering brand new ways to use this software. One example was a physician in Austin, Texas, who was trying to plan a separation surgery for Siamese twins, and so he had to look at the babies in the uterus through a CAT scan, and then plan, once the babies were delivered through C-section, how they were going to separate them. And they were able to do all that before the babies were born, and then they successfully carried it out. So I mean, that's way above what I'm doing right now, but the power of this program is really overwhelming. You know, it's amazing what people are able to do with it. And like you said, it's highly customizable for people.
So how were you able to get this for free?
Yeah, well, basically by not agreeing to pay their somewhat exorbitant fees. So they made an offer, and we just said, hey, we're a small community college. There's really, you know, that's just not in the cards for us to try to approach. So you know, things kind of went radio silence for a month or so, and then they wrote back and said, well, look, you know, we're changing some things up about how we're operating with you know, educational faculty, and we're willing to work with you. And so they're giving us this license for 24 headsets, and then also the teaching headsets, the Quest 3s. So that'll be enough time to implement them in our next semester. And then we're gonna hope that they decrease the licensing fees a little bit more once we show that we're producing good content and that kind of thing. So
That's
yeah,
pretty
so that's
cool.
where we're at. Yeah, yeah, it's
Rob,
exciting.
can I ask you, how did the students feel about using this?
Respond to it. Well,
Yeah.
yeah, one of the concerns was, students that had issues with like motion sickness or other kinds of problems. There's a whole variety of things that people might object to. One of them was, passing these headsets from one student to another. And one way we've come, one way we've kind of dealt with at least that last problem is we are only going to be having one student use one headset for an entire semester. And so, they can adjust it and have it kind of tuned to their eye width, and that solves a lot of these problems. Not having to pass them from one student to another solves another series of these problems. And we're lucky. We're lucky that we're able to use 24 of these headsets all at once to deal with some of those what would be otherwise issues for us. So, but there's always we haven't run it with a big class yet, so there's always probably going to be situations where students just aren't comfortable with it, and in that case, we'll try to deal with that as it comes. You could see kind of what was going on in a 2D way. We have that option in the class as well. So.
Well, at this point, I think I'm going to stop the recording, and we'll get this up for everybody to see.